and welcome to the Holistic Half. Now this episode we're going outside of the box. Generally the Holistic Half covers topics that affect your natural health in usually modalities or different ways. But because so many of the shows that we've done, their emphasis was on the water that we intake. So today joining me is an environmental chemist, Jim Maloney from Newport, Rhode Island, that's going to talk to us a little bit about water and its composition. So Jim, welcome to the show.
Well, thank you. It's nice to be here.
And if you can tell our viewers just a little bit about yourself and what you've been doing the last 23 years.
Well, I graduated college with a degree in chemistry and started working in the environmental field. Back 23 years ago, hazardous waste regulations were coming into play, and we were disposing of industrial wastes, paint thinners, cleaning solvents, in direct response to environmental issues such as our lakes being on fire.
Right. And what made the transition into the waters?
Well, the environmental regulations that I've been working on for the last 23 years were enacted in 1976. And a lot of chemistry has been invented between 1976 and today.
Right.
That's not regulated.
Right.
And it was surprising to find that although the EPA is studying these materials, they're actually not regulated. And what I'm specifically talking about is drugs in the water.
Like drugs like pills or?
Pills, pharmaceuticals. There's a lot of talk these days about drugs being in the water or medicines, pharmaceuticals. They've always been in the water. And part of the issue is that we're able to see them now.
Right.
And the work that I've been doing revolves around a specific type of chemical or drug. It's called a chemotherapy drug.
Now, tell us this, how did that even get on your radar?
Well, I got back into the environmental business about 2 years ago. And I was working at a hazardous waste facility, and the guys in the back actually doing the work were working with a syringe, and they had a needle, and they were taking the syringe and they're breaking the needle off and putting it in a medical waste incineration bucket. And they're taking the other syringe full of the chemical and putting it into a non-regulated waste container that we sent for trash incineration. And the question was, what are we working with?
Right.
What are you working with? And the answer at that point was, it's not regulated, so we don't really care what it is.
So they had no idea what the chemical was, and they weren't asking any questions because it wasn't regulated, therefore they assumed it was safe?
Yeah, pretty much assume it's safe because of the outdated regulations that we have. So when I did a little research into it, I found that they were working with some medicines, and the medicines happened to be chemotherapy drugs.
Okay.
And if you take a look at the severity of some of these drugs and how they react in the body and the levels at which they're effective, they're very dangerous.
So how do you know what chemotherapy is, basically? Like, I have no clue, like, as far as it's a medicine, but why would that be dangerous to these employees?
Well, that was the question that I had. I said, well, what are you working with? And just because it's not regulated doesn't mean it's not dangerous.
Right.
So I went to the health and safety director and asked, what are we working with? And with any chemical that you work with, it has a biography, so to speak. It's called a material safety data sheet.
And who provides that?
The manufacturer provides this.
Okay.
Now, this specific chemical that they were working with is a drug called Mustargin, and they had a material safety data sheet for it. And when I read the material safety data sheet, as with any drug, it has a side effect.
Right.
Now, some of the side effects, you can't watch a commercial without them telling you what side
Without
effects you have.
100 of them listed,
It's listed. Well, these drugs have some serious side effects, and one of them is, it says right on the material safety data sheet, may cause cancer.
Oh, geez.
May cause hereditable genetic damage.
So it means that it
causes damage
to your DNA
to your offspring.
Oh, geez.
May cause harm to the unborn child.
Right.
And the guys across the street were working with a non-regulated material that they assumed was safe.
With their bare hands.
Well, they had gloves on, but there's respiratory effects to it. And this material is toxic by inhalation. And so what I did is say, we're not going to do this anymore. And we're going to take a look at what we're handling, even though it's not regulated under a hazardous waste regulation. I found that they were regulated heavily under the Occupational Safety and Health Administration, the
OSHA, what everybody knows, yeah.
And what was troubling is the disparity between the amount of regulation that goes on manufacturing these drugs, these chemicals, the preparation of these drugs by the pharmacist, the regulation on the nurses that handle the materials.
Meaning that you can't touch these, you can't breathe
OSHA
them.
has a zero exposure. And they have a protocol for handling what OSHA determines to be hazardous drugs. Which have the technical manual here is one of the, we're going to show this, is one of the major documents that I reference in all my research. And OSHA has been studying this for 30-something years.
Right.
And one of the studies in there that's very troubling is that they tested nurses that handle oncology that handle oncology drugs, and they found that they had a spontaneous abortion rate of 4.7, which is almost 5 times the normal, just handling these drugs.
So all the care and precautionary measures were taken in the hospital and in almost like the front of the house kind of thing, but then what's happening in the back of that? Like once it's administered to the patient, well then what happens?
That was one of the problems that I had with just them throwing the chemical away because it wasn't regulated and we were handling it. Then I got into some further research where if you think what happens to these drugs when they inject it into the patient. And if you ever take a vitamin, you haven't taken one in a while, and you go to the bathroom and your urine is bright yellow.
Yeah. Like asparagus.
Yeah, it looks or it looks like you ate a highlighter or just something.
You can tell it comes through, yeah.
That's the chemical passing through the body, unaltered. Now, vitamins your body needs, so your absorption rate on a vitamin can be 5 to 50%. It varies. And any sort of a chemical or a medicine has an absorption rate. So the material that's not absorbed goes somewhere. And which isn't a big problem with vitamins because they're not very dangerous at low levels.
Right.
With these cytotoxic drugs that OSHA has determined has a zero exposure, and goes to such extent to protect the people manufacturing it and processing it.
Now just to stop for a second, what's cytotoxin?
Cytotoxic it's a process. A cytotoxic agent is a chemical that breaks into a cell. It'll attack the DNA and break off the chromosomes. So for a cancer cell, a cytotoxic agent as a chemotherapy drug, it'll break into the cancer cell, it'll attack the DNA, it'll break off the chromosomes, so when the cell splits, it's been mutated. It's no longer a cancer cell. We've cured cancer.
Right.
If it's a hair cell, it's no longer a hair cell. Your hair falls off. If it's a skin cell, it's no longer a skin cell. Your skin falls off.
I gotcha.
So that's what the term cytotoxic comes from.
The chemotherapy drug is a cytotoxic drug.
Yes.
You ingest it, and then what's the absorption rate?
Absorption rate on a cytotoxic drug is very low. They vary.
Yeah.
I use the 1 to 5%. Gets into the cells. In some cases, it's much less than that.
And what's normal? Like, is that normal for most drugs?
Most drugs
Or
have
vitamins?
a 5 to 15%, and they do vary.
So only 5% of whatever you take in stays with your body. The rest all comes out in one way or another.
It can vary. Some of them are 100%, but it varies
Oh, really?
on drugs. But for the
Okay.
most part, they do pass through your body. And that's when we talk about drugs being in the water. The EPA estimates that 85% of the drugs that are in the water come from people taking them properly
and then
and
just
it's
passing
through their
rest.
body.
And then what's the rest of the percentage? It's from dumping, like they say, dumping in the toilet.
Yeah, they say 5% is from people just disposing of drugs improperly.
And
just
why do they
flush.
do that?
Well, if you read the label, it says to flush down the toilet. It says flush, federal, state, and federal regulations mandate that you flush the pills so that they can't be reused, so children don't get hold of them, or they get sold on the street for street value.
Okay, so now this is my question. Now everything's in the toilet. How does it get from the toilet to the water supply?